Perfect square trinomials. Tell me first of all, what's a trinomial?
Something with three.
Something with three terms. You're absolutely right. Y'all didn't pod back up today. It's okay. We can pod up whenever we get to work. All right, something with three terms. And we know what a perfect square is, yes? Sure. Give me an example of a perfect square. 49, 4, 16. Somebody give me a perfect square without any number to it. X squared. Good job.
Oh, I said it was X.
So perfect squares do what? Tell me what a perfect square is.
They can be divided evenly between each other.
Close. I think you think.
Two numbers go into it. Two numbers
Yes.
that's
Multiplied by itself gives you that. I know that's what you meant. Yeah, yeah. All right. So here, because 4 times 4, right? X times X. So we're all aware of what perfect squares are, yes? All right. And the trinomial we said has 3 pieces. So remember we talked about, and we just talked about it briefly, but we talked about a special pattern that was easy to factor that you didn't actually have to think too much about. It had a look like this. And you said, oh, that's easy. We figured out the pattern quick, and I told you it was called something. Do you remember what it was called?
Perfect square finding.
Close.
Oh, that's 2 of
So
them.
give me another word for subtraction. Minus. Give me another one. Difference. Difference.
Between 2 squares.
Yes. Difference of 2 squares. Sam got it. Remember talking about this?
No.
Y'all don't? Difference of 2 squares. We talked about it while we were going over our homework one day. And we said this factors as what?
X minus 7, X minus 7. Or wait, X plus 7.
There you go. And it only works
Oh, yeah, we do that a lot.
when this is a subtraction sign, right? If this were x squared plus 49, this wouldn't work. Do we all agree? Because it's got to be opposite signs to add to 0 in the middle. Now, a perfect square trinomial is another one of those little patterns that if you recognize it, it's very easy to factor. But we're going to have to recognize it for what we're doing today as well. So let me tell you the pattern. We have 3 terms. 1, 2, 3. Okay? The ends are perfect squares. So I'm going to call this a squared. I'm going to call this b squared. The second sign must be plus. It's got to be plus. Which means the first sign can be either or. Now tell me what's special when the second sign is plus anyway in terms of factoring.
It copies the first sign.
Copies the first sign. Both signs are the same, right? If this one is a plus, then no matter what I do, it's either going to be like that or like that, depending on what this first sign is, right? They're going to be the same. Okay. Now, here's what we have to think about a little bit. The middle term is special. The middle term is special because you have to look at the ends to get the middle term. So what happens, Miss Wilson and I like to say that the trinomial has to square dance. If you take the square root of the first, which if the first one is a squared, what's the square root of the first? A. And you multiply it by the square root of the last one, b, and you double it. Okay? So you do square, square, multiply, and double. Square root, multiply them together and double them to get what's in the middle.
Why did you do that?
The what? All right. If this, and I'll show you with an example too. I always like to show you with the variables in general, and I'll also show you. Some people like it either way. All right. If that's true, so that's a lot of stuff you got to check. Look what you got to check. You got to check square root. Square root. Actually, perfect square, perfect square. You got to check that this sign is a plus And you also have to check that the middle term is the product, double the product of the square roots of the ends.
Yeah.
Now that sounds difficult, but it's really not. If all that's true, it is an easy factor. It's going to be the square root of the first one, the square root of the last one, and whatever this first sign is, goes right there. So A, if it's plus here, then this sign's going to be plus. If it's minus, this sign's going to be
And then
minus.
still have to split it.
Right.
That's it.
Okay, but we're going to use it to do something. But first, let's do several examples and make sure you can recognize a perfect square trinomial. All right, let's see.
X to the second minus 16x.
So they look just like the other one?
Whoa, 6.
Okay.
Yeah.
I only got 3 on this time. Oh, just to make sure the first one and the last one.
I'm gonna pause this a second. All right, let's look at these three here. Juliana has already caught
I'm sorry.
one of them. It's okay. That's okay. That's okay. Look at the first one. My first question to you is it a perfect square trinomial? PST. Yes. Is it? Yes. Reason being, you got some things to check off. Are the ends perfect squares?
Yes.
Yes. Yes and yes. Is the second sign a plus?
Yes.
Is the middle term the product, double the product of the square roots of the ends? That's a mouthful. Yes. In other words, does it square dance?
No.
What's the square root of this?
Yes.
What's the square root of this?
8.
X times 8 is what?
8.
8x. Now double that.
Oh, yeah.
Is that what's in the middle?
Yeah.
Yes. So the middle term also checks. So to factor this, I would take the square root of the first term,
X
the first sign,
minus
and the square root of the last
8.
squared.
And that's it right there.
Wait.
Oh, yeah, look at us smile. So,
Look at the second one. Somebody please tell Miss Young Evans we used pink and green today. She should be so excited. All right, look at the second one. Is it a PST or not?
No,
Why?
I just said.
This
Why?
sign. That sign alone is enough that I don't have to check anything else. It cannot be a PST because the second sign has to be positive.
And how did you get?
Is it PST now? Yes. How did I get what? Juliana?
Oh, we just square root of 64.
Yes, yes. Does everybody see why the second one's a PST now? The ends are perfect squares, yes? Is 4x squared a perfect square?
yes.
What times itself twice gives you 4x squared?
2x.
2x. If you take the square roots of the ends, so 2x and what's the square root of the other end?
That's
So
10.
you want
5.
to put on a positive.
So that equals 10. Oh, yeah, it is. Because 2x times 10 equals.
Multiply those together and double them. Do you get what sits in the middle?
Yeah.
Then it factors as 2x plus 5 squared. Easy?
Even though you can't really change the positive if you're doing it, right?
Correct.
So this is just a hypothetical one.
Right, yes. I was just saying, I want you to be able to recognize that even the most minute change done to the problem can cause it to be not a PST or can be a PST, but you have to be able to recognize whether or not it is. How about the last one? Yes or no? Probably no. I hear yes and I hear no.
Yes.
It is. Yeah, because they got a plus sign and they both
There
square
it is.
root.
This is plus, this is a square root, you say?
Yeah, 4 is 2 and 2.
X squared.
2 and 2, 3x squared, absolutely. Multiply them together and double, you get what's in the middle?
Yes.
So first term, first sign,
Okay.
last term.
Oh, I should be way harder on homework.
But 3 times 2 does not equal 12.
Double it. Remember, you got to multiply and double. Square, square, multiply and
Oh, that
double.
is right.
Yes? One more? Are you good? One more. I heard one more. Yes or no?
Yes.
Yeah.
5x and 3.
I heard yes, so let's go through.
Yes.
But that ain't gonna
Equal.
that ain't gonna be right.
Oh, why?
5 times 15, then you gotta
You've
double
got to
It's gonna
double
be
it.
Boom.
What could I change to make this a PST?
Change the negative 15x to negative 38.
So how would it factor then?
You can't do it.
You can't?
If I change this to 30, how would it factor? 5x, absolutely. Minus 3 squared.
Wait.
I changed the problem. I said, what would I have to change? Oh. So 5 times 3 is 15.
So you take the first sign and you put it in there.
Yes, because this is the same thing as 5x minus 3. 5x minus 3.
Right?
No, you can, if you recognize it being a
That's why you
PST.
double it,
Now,
right?
right, well, and if you,
Recognize it not being one,
do what?
it's like this, the original equation. Are we allowed to?
No, you can't change it, no.
Okay.
We're going to do some manipulation. I'm showing you this because we're going to do some manipulation of equations to make them PSTs today.
Right? But it's not homework.
Yes, it is on your homework.
Then why did you say that?
Don't try to think about manipulation yet until I show you what we're going to manipulate and how we're going to manipulate. Okay. I could still put this in the box. If I put it in the box and factor it, I would get 5x minus 3 up and over. Okay? So you can still use the box, but if you think about it when you put it in the box, 25 times 9 is a pretty big number to try to find factors of, right? So it's a shortcut if you recognize that the ends are perfect squares. All right, tell me this. Riddle me this. No, I'm just kidding. Shut up, Stacy. Just shut up. Okay. Force that to be a perfect square trinomial. What would need to go in that blank there?
You gotta do something like that too?
You would need 4.
What would have to go there? Somebody saying it. You would need 16 or 4.
Wait.
Hold on real quick. That's 16. I think 16. Hold on, let me see. No, I think 4. I don't know though. Let me see.
All right, set them up.
My godly power.
Write it out. One of these is a PST and one of them is not.
X times 4.
Yeah, it's 16.
It's 16. What did you do?
No, it's not.
We square root.
Okay, wait. Let's make sure everybody understands that it is 16. Remember PST. Square root, multiply, and double. What's the square root here? X. What's the square root here?
4.
Multiply it together.
4x.
Double it.
4x times 4x.
Double it. Not times it by itself. Double it.
Oh boy, that's why I was messing up.
All right. So are we all in agreement that this is what would need to go in there to force it to be a perfect square trinomial? Yes? How did you, if I was thinking about going backwards so that I could always, if my first term was a perfect square, what kind of formula could I set up, or what could I do so that I could always find that n number there to make it a perfect square trinomial? What did you do? Go in the right order though. Divide it by 2. What did you divide by 2? The 8x. I'm going to go back to my thinking of ax squared plus bx plus c. Ooh. And I'm going to reference it that way. So I'm going to say you divided by 2. Isn't that what you said? Divided by 2? And what? You divided 8 by 2 and you got 4. But that's not... It's not,
Multiply it by itself.
which is doing what?
It's basically square rooting 16.
Multiply by itself, it does what?
It would basically be square rooting.
Squaring, not square rooting.
But like, no, whatever.
Okay, but you don't
back-
have the 16 right now.
Yeah,
If you
but
were
like if whatever you get.
right.
Just doing it
But if
backwards.
you didn't have this, how did you come up with this? Is what I'm trying to get you to get to.
Yeah.
Is given just this 8 and knowing this is a perfect square,
To the second plus
you
8x.
divided it by 2 and squared it, right? That gave us what I'm going to call a good C. A good C meaning it makes a PST. Okay? Am I making sense to you right now? This is only working when my leading coefficient is 1, which is really the main thing we're going to be doing right now with completing the square. What you just did is what we call completing the square. I gave you 2 terms and I asked you to complete it to make it into a perfect square trinomial. What would you have to add to it to force it to be? And then we came up with this little equation. Our good C is going to be half of B squared. Does that make sense to everybody? Let's try another one. I'm giving you the formula now, but I really wanted you to kind of come up with it on your own, and you did. All right, let's look at this one.
I thought they give it to you for free.
They did.
But they like
Let's say, oh, no, that's what we just did. Ah! Tell me what your C needs to be to make that be a perfect square. What do I need to add on the end here? See how easy this is? Half of the middle term, since the end, remember it's got to have this coefficient of 1 leading coefficient.
9.
Yes. B over 2 squared, which is 9, and it's going to go here.
6 over 2. 6 divided by 2, 3. Oh yeah, you know I'm better than that.
Okay? How would that factor?
Exactly.
How do I factor?
That would be
It'd be what?
x minus 3 squared.
Good job. Yes.
I'm gonna go back on the last slide when you think.
Let me just show you one more thing. Let me make sure you remember. You should know how to do this.
Now we got something extra to do.
If I asked you to simplify that,
I don't know.
no decimals.
I'll crack.
I remember how to.
You remember that, Grant?
I think I do.
2 times 5.
Well,
2 times
2
5.
times the square root of, or 5 times the square root of 2. Yeah. Remember, you're looking for, you think about your perfect squares. 2 to the second power is 4. 3 to the second power is 9. 4 is 16. You look for the biggest one you can divide this by,
Oh, the factor trees?
and then you break it up into those two. Do y'all remember
I
that?
remember I missed that during school and I was so confused.
Okay, we'll do a whole nother lesson on that, maybe tomorrow. Maybe tomorrow we'll do that. Right now, I'll just let you leave it the way it is. Let's look at the application of our PST here. Let's say I have this equation.
to the second plus 66. Oh, no, what?
Let's say I have something that looks like this. Okay. And my directions say solve by completing the square. Okay. Solve by completing the square. Now, in order to complete the square, I must have a perfect square trinomial. Look at just the left side. What is keeping me from having a perfect square trinomial on the left side? The 5. The 5 has got to go, right? I'm going to call this a bad C. Why am I calling it a bad C?
You just don't like it.
I don't like it.
Because it's not a perfect square.
It's not a perfect square. It's keeping me from having a perfect square trinomial.
You would have
So forget that C. What I can't really just forget it, but what could I do with it to forget it? Erase it. I can't just erase it and do away with it. I could move it, right? I'm going to move it
to the other side.
to the other side.
So 7 minus 5 is 2.
So now I've got, what's your question, Tanner?
Why are we moving to that side?
Because it's not a perfect
Because to complete the square, I have to have a perfect square trinomial. And so I want this side to become a perfect square trinomial. It's not right now. What's keeping it from being a perfect square trinomial is that 5 right there. So I'm going to move it. Whenever I move it, though, I'm going to leave a little blank here, a little room to work, because what I want to do now is I want to find a good C to put in that equation.
There.
You're going to also have to put a plus sign.
I'm going to have to put a plus sign. What wasn't there, Tanner?
You're adding something that wasn't.
But I can do that in an equation as long as I do what?
Go backwards.
I do it to both sides.
Oh, yeah.
I just have to stay balanced, right? I am manipulating this equation, so I'm forcing it to be something it wasn't before to make it easier for me. So now my question is, what is your good C? What number going in there, in that pink space there, would force a perfect square trinomial? 25. How did you get that?
You do the thingy.
5 times 1, 5 squared.
P over 2 to the second.
Please tell me you think it's harder than
10 over 2, 5 to the second.
When you find that good C, it's got to go on both sides.
Wait, where'd you get the 10 from?
The middle term here.
I put 5 never mind.
Are you following me? I'm kind of putting you some steps in here as I go to tell you, so when you go back to look at this example in your notes, you see some. So directions are solved by completing the square. The 5 was the bad C. I moved the bad C, and now I'm finding a good one.
So then we're going to do 2 plus 25.
All right, so now, so now look at my equation.
25 equals 27. Is that right?
Now I have, x squared plus 10x plus 25 equals 27. Now factor the left side.
Minus 25.
Factor the left side. How does it factor? X plus 5 squared.
That was not a lot of work.
Is everybody with me?
Yeah.
Do you see what we did? Because if I was asked to solve this initial equation for x, it'd be kind of hard, right? Because this doesn't factor. I can't put it in the box. I can't set it equal to 0 and factor it. It won't factor. But I can complete the square. All right. Now, why is this easy to solve the way it is now? Can you tell me what x equals? Remember, solving, I'm undoing what's already been done.
X squared plus, we'll just be bringing it back.
Wait, do you plug in 0?
You can't.
Oh,
13.
What order do you solve an equation in?
Something else.
film this.
PEMDAS is simplifying. Have y'all never had a teacher teach you this?
Backwards PEMDAS?
Wait, which one?
SADMAP, backwards PEMDAS.
I heard it.
When you solve, because solving undoes simplifying. Oh my goodness, how did you ever know what order to solve an equation in?
Something zero.
We had like these two like
We would do,
Right, to simplify. That's to simplify though. But what if you were just
Sad
please
milk.
excuse my dear son, that's what,
how would you know what order to do that in?
exponents first.
That's simplifying though. If you solved this, how
Add 5 to 12.
well, why are you adding 5 first and not dividing by 2?
Because that's how
Why?
you do it. That's just how you do
That's the only
it.
stuff you can do.
You gotta get
You do have to get x by itself, but how do you know that you add 5 first? Because y'all are listen. Y'all are telling me
Wait, you can divide by 2.
y'all are telling me PEMDAS to solve. Listen,
I
this
think
is going to be
I've
crucial.
heard it before, and I think they taught us this before, but
All right, listen, this is going to be crucial, guys, because our equations are going to get more and more complicated. And you need to know the order in which to solve them. That is, I'm appalled. Okay. You told me you solved them PEMDAS. If that's the case, multiplication division would come first and you would divide by 2. But you told me when you solve this, you need to add 5
It
first.
doesn't matter.
Yeah, we told you to do
They told you what to do solving like a 2-step equation, but they never told you why.
that's
All right.
perfectly how it is.
If you divide by 2, that's 10. Negative
Oh,
5
my.
is 10.
Whew. Okay,
I'm
yeah.
sorry, I didn't hear anything.
Because PEMDAS, we use PEMDAS, guys. We use PEMDAS to simplify. That is the order of operations. But solving is not simplifying. Solving is undoing. It's going backwards. So to solve, we must go
Backwards.
in the reverse order.
sad milk.
Okay? So now go back and look at my equation that I had.
You subtract and add, and you divide
Right,
by
yes. Remembering that parentheses come absolutely last.
Wow.
Because we're undoing, we're solving. You're doing opposite operations. Everything's backwards when you solve.
Why has this never been?
I do not know. Elena, you've done it before. Well, you had me in Algebra 1. Yes, Shami, yes. I had you too. Okay. So now look at this. Look at this equation. Look at this equation. When you see x written only one time, even though if you were to multiply this out, there would be more than one x. When you only see one x in the equation written one time, you can use SADMAP to solve, okay? Inside parentheses is last, okay? Because it comes
And
last.
its exponents are also second to last.
So I don't have any addition or subtraction outside of parentheses. I don't have any multiplication division outside of parentheses, but what do I have?
The exponent.
An exponent.
So
How
you
can I get rid of that?
You can multiply 2 into
Multiply everything inside by 2.
Take the square root of both sides.
Square root. Do you guys not know opposite operations of square root?
No.
What is that?
Plus
What are
5.
we doing? I'm so confused.
Let's digress one more second because I didn't know that y'all didn't know the opposite operation of a power of 2. What is, when we solve, we do opposite operations, right? We add 5 to both sides because the opposite of subtraction is addition, right?
So then the opposite of division is multiplication.
The opposite of division is multiplication. What is the opposite of a power of 2?
Square root.
A square root. In other words, what cancels it out,
The square root.
right?
I think we've done this before.
I think you should have had this in Algebra 1 for sure.
It's just that we probably didn't go on it for so long.
Okay, so now back to this equation. If I wanted to get rid of that power of 2, what would I do?
Square root of 8x and 5 x. Oh yeah, I've seen this.
We're going to take a day to talk about simplifying radicals. For right now, leave it like that. It is a plus or a minus, though. Why is it a plus or a minus? Why is the square root plus or minus? Huh?
Because you don't know what x is.
The square root of 4 can be 2. The square root of 4 can be negative 2. Why?
Because you could do negative 2 times negative 2.
Negative 2 times negative 2 is positive 4. Yes? Okay. So now how do I get x by itself? Subtract 5.
Wait, how did you get square root of 4? What?
This was just a little side note here. Why it was plus or minus.
We can be both plus or minus.
Yes. So now x is negative 5 plus or minus the square root of 27.
But you just took away the square root of 1. Well, did that just make the parentheses go away too? Whenever you square rooted it?
What
Square
parentheses?
rooted.
Yes, yes, because it was that squared was going to everything.
So then the square root itself went away as well.
Correct.
Breaks itself out of jail.
I think that we are going to need to practice solving some equations tonight.
No, do not.
I don't even know.
You just told me. No, you not.
Let's look at an example start to finish without digressing to do other things and see what you think. X squared minus 10x. Is that what we just did? Oh my goodness, I'm losing my mind.
Plus 10x for the other one.
Minus 8x plus 4 equals
Second minus 8,
31.
equals 31.
Whoa, it's such an odd.
How?
Solve this by completing the square. Listen, guys. First thing I want to do is check to see if it is what? A perfect square trinomial. Is the left side a perfect square trinomial? No. Why is it not?
Because the 4 is positive and then.
What's the square root?
X?
What's the square root?
2.
Multiply those together
It's 2.
2x.
and double it.
4.
Is it a perfect square trinomial? No. So is that a good C or a bad C? What do we do with bad C's? We move them. Minus 4 minus 4. So now I have x squared minus 8x. Leave a space because I'm going to find a good one in a minute.
And then plus.
What's 31 minus 4? 27. Again with the 27. All right, I need a good C. How do you find a good C?
The little thing.
You're right, Rosa. The little thing. The good C is take the B, divide by 2, square it. It has to go here and here.
Yup.
Take half of the middle and square it to find a good C. But because I'm in an equation, I can't just add it to one side. I have to add it to
Why
both.
would it be negative 8?
Don't put
Why
the
would
sign
what?
of attention.
Why would you put negative 8?
The first sign doesn't matter. All right. Factor the left. How does it factor? It does factor evenly. Factor it. Square root of the first sign, square root of the last, squared equals what?
How'd you get x minus 4?
This is a PST, so I factored it like a perfect square trinomial.
Yeah. Oh, I got it. Oh, equal 53.
Of 6.
Yes. I think tonight I want you to get to this point. We'll digress tomorrow and talk about radicals and stuff, but let's just work on forcing PSTs tonight.
Just stop at this point right here.
We're not going to solve all the way. We're going to force PST. Let's do one more.
X minus 4.
Why can't we just go off?
Why is it 23?
Are you comfortable going all the way?
Can we go all the way on this one though?
Okay, yeah.
Why is it 43? How did you get
Okay, that good C has to go to both sides, Juliana.
Oh, yes.
You didn't have to say that. Right?
Isn't after this, you just square root both sides,
Yep.
and then it's
You gotta add it to both sides.
plus
Yeah.
the square root.
Yep.
It was on there.
It's really not hard to finish up this problem like this because, yes, Rose is right. You just square root.
Yeah, square root.
You just can't forget the plus or minus here. And then add the 4. I'm not combining it. I don't want decimals. I want exact answers.
Oh, this we hate decimals for some reason.
Because
All math teachers here.
decimals are...
Everyone's like, oh my god, fractions are the best.
Because decimals are an approximation unless they're... Yeah, 0.5 is
What
not,
is
but...
wrong with
If I ever
decimals?
see a decimal, you are getting a point off.
No, they not. Decimals are real.
All right. Shh. Be very careful because I don't want you to worry about it right now, but this is only working because my A is 1, so my first term is always just 1x squared. The square root's always x. Can I make it a little bit harder?
No. I'm joking. Yeah.
No. Alright, let's see if this is proof. Oh!
Okay.
X, that's X.
Is it a perfect square
We gotta
trinomial?
get a new
No,
C.
it's not.
It's a bad C. We know that right off. Let's move it. Now look, if you've got a good C to start with, go ahead and factor and you're good to go.
So 3 minus 5?
X and C.
Plus 5. You need to move it. All right. Is anybody ahead of me and figured out why I said this was a little bit more difficult one?
Yeah.
You see one, wouldn't it?
Yeah, the square.
Not just that.
There's no, there's no square root in that.
What's your good C?
Nothing.
Is it 1?
Nothing.
If I put 1 in that equation and I take the square roots of the ends and multiply and double, do I get what's in the middle?
No. No, you don't.
Wait,
It's 1/2.
how would you do
Oh.
Look,
Oh, yeah.
if this was 1, right?
It would equal.
I would have x and 1 together would be 1x, doubled would be 2x. That's not what sits in the middle. So I need to use that. So now's where you really need to think about how we came up with that formula.
You're going to use 0.5.
We're not using a 0.5, Shamik. We're going to use 1/2.
Can I use 0.5?
B over 2 squared.
Fractions ugly.
Do you all agree with that?
Man, I can't do that.
Yes, you can.
Decimals. Decimals make no sense to me for some reason. Ain't no 8, no 1.
All right, look.
Then we have X.
Why do you even do that?
Look.
Why do you do plus 140?
You always add it.
I'm
The formula for a good C is B over 2 squared.
So 1x.
Your B
1
is
over
1.
I got it.
2 squared. Okay. Oh, okay. Yeah, I see that.
Yes?
And then you add.
Do you see why it is a perfect square trinomial? Take the square roots of the ends. What's the square root of the first term?
X,
What's the square root of the last term?
25. 1/2.
1/2. Right? What's 1/2 times 1/2?
1.
1/4. 1/2 plus 1/2 is 1. 1/2 times 1/2 is 1/4.
I don't know how to do practice. I'm a decimal.
So if the square root of the end is x and 1/2, if you multiply those two things together, what do you get? I have the attention of about a third of you. What's the product of the square roots of the ends? The square root of the first one's x, the square root of the last one is 1/2. Multiply those together, what do you get? What's x times 1/2? 1/2 x, double it. 1x. 1/2 doubled is 1. Is that what sits in the middle? We have a perfect square trinomial. So factor it now.
Okay, so now we're just gonna remember
What's the square root of the first?
X
First sign,
plus
square root of the end,
equals 8 and 1/4. Oh. No.
we don't do mixed numbers in here. Mixed numbers stink. Does that make sense?
I totally forgot.
No, because it's fractions, or no, because the whole process doesn't make sense?
I have to say that.
Miss B, can I use the bathroom real quick? You said yeah?
Never.
Please.
Let's not even solve. Let's just find the value that makes it a perfect square trinomial. A good C. Remember your formula for a good C. B over 2 squared. Yes? What is B? 1/2. Instead of dividing by 2, what can I do?
Multiply by.
Close. Multiply by 1/2. This is like 2 over 1. So flip it to a 1/2. What is half? What is it? 1/4
But half
squared.
divided by 2 would be 1/4. 1/4.
Half. Right. And 1/4 times 1/4 is 1/16.
Okay, so that would have just been easier.
And you have to do that to find out what you add to both sides, but in terms of just factoring, the square root of the first is, the square root of the last is,
Isn't that what we just put?
does that make sense to you?
Uh,
I feel like if we didn't have so many holes to fill in the beginning, we wouldn't have gotten as confused as we did.
I would understand it more if I had this piece of paper.